Good afternoon, all. My name is Professor Swami Reddy, Department of Mathematics, SR University. In lecture 1, vectors, we discussed about the vector applications, daily life applications, and some fundamental definitions of vectors, right? And position vector, unit tangent vector. These are all discussed in lecture 1. Next, in lecture 2, we are going to discuss vector differentiation. How we take the differentiation of a vector and some applications of vector differentiation we are going to discuss. Here, the vector differential operator is nabula, right? Or this is also del. Del is equal to I bar dou by dou x. Partial differentiation. J bar dou by dou y. K bar dou by dou z. Right? Del. Now, gradient of scalar function. You know, this is a scalar point function. Is a function of x, y, z. Right? Then the gradient of phi is denoted by del phi. Del phi or grad pi. Grad pi. Del pi or grad pi means there is no product operator between del and pi, simply del pi. There is no cross product and dot product. So what is del? I bar dou by dou x, j bar dou by dou y, k bar dou by dou z, dou by dou z into pi, right? So then we multiply, that is I bar dou pi by dou x, j bar dou pi by dou y, k bar dou pi by dou z. So partially differentiate pi with respect to x, with respect to y, with respect to z. So this is grad pi or del pi, right? Now let's go to the some problems on vector differential operator. Here find del phi. Here phi equal to log of x square plus y square plus z square pi. Now del pi I bar dou by dou x, j bar dou by dou y, k bar dou by and log. So multiply I bar into this log of x square plus y square z square plus j bar into log of uh, y square x square plus z square with respect to y, partial differentiation with respect to y, with respect to x, and with respect to z, right? You know the derivative of log x is 1 by x, right? And derivative of x is 1, right? So similarly here, log of x square plus y square plus z square with respect to x, partial derivative with respect to x, dou by dou x of log of x square plus y square plus z square is 1 by x square plus y square plus z square, and derivative of this x square plus y square plus z square with respect to x. So x square derivative is 2x, y square derivative is 0, z square derivative is 0. While partially differentiating with respect to x, keep y is constant and z is constant. Their partial derivatives are zeros. So dou by dou x of log x square plus y square plus z square is 2x by x square plus y square plus z square. Similarly, dou by dou y, 2y by x square plus y square plus z square. Similarly, log of x square plus y square plus z square with respect to z, 2z by x square plus y square plus z square. Now let's take the LCM is x square plus y square plus z. Now 2x I bar, 2y j bar, 2z k bar. This is a del pi or grad pi. Grad pi. The pi is any scalar point function, right? And next, del pi or grad pi, find at the point here. Point is given 1, -1, and 2. Here pi is x square minus y square minus z square minus 2. So similarly, just write down what is the differential operator del this one, and into x square plus y square minus z square minus 2. Now with respect to x, partial derivative of this x square plus y square plus z square minus 2 with respect to x this is 2x, simply y square is 0 with respect to z square is 0, constant is anyway 0, so this is only 2x. With respect to y, this is 0 and this is 0, so only y square derivative is 2y, right? This is plus, right? This is plus, not minus. Y square, x square minus y square, minus y square, so minus 2y, plus k bar z square, so minus 2z. Right? This is 0, this is 0. So 2x I bar minus 2y j bar minus 2z k bar. So at the point, put x is equal to 1, y is equal to -1, z is equal to 2. So 2 plus 2, here minus into minus, y is equal to -1. So 2 I bar 2j bar minus 4k bar. This is the del pi or grad pi at a given point. And next is directional derivative. The next, using differential operator, vector differential operator del, can find the directional derivative. So the directional derivative of a scalar point function phi is any scalar point function. If you want the directional derivative of the scalar point function at a point p, x, y, z in the direction of a bar. A bar is a vector in the direction of a bar is given by del pi dot a bar by magnitude of a bar, del pi dot a bar by absolute a bar or magnitude a bar. So here a cap is equal to, where a cap is equal to a bar by modulus of a bar, right? This is a cap. You can call this a cap. This is a unit vector. A cap is equal to a bar by its magnitude, absolute of a bar. This is the directional derivative formula. What is that? Del pi dot simply a cap. A cap is equal to a bar. Now let's take the problem. Find the directional derivative of pi at the point 1, 2, -1 in the direction of this 2i bar minus j bar minus 2k bar. Here del pi equal to, just first calculate del pi, then find a cap, then take the dot product between del pi dot a cap. This is a dot product between del pi and a cap. This is dot product. You know, I dot I bar dot I bar is 1, j bar dot j bar is 1, k bar dot k bar is also 1. Right? We'll see later. Now del pi, what is that here? Pi, scalar point function, x square yz plus 4xz square. Here del pi is I bar of dou by dou x of this x square yz plus 4x plus 4x z square with respect to x. X square derivative is 2x, y is constant, z is constant. Next, plus 4x z square. X derivative with respect to x is 1 z square. So 2x yz plus 4z square. So this is 2x yz plus 4z square. I bar. Similarly, with respect to y, dou by dou y of this x square yz plus 4x z square. So with respect to y, x square is constant, y is 1, derivative of y with respect to y is 1 into z plus 4x z square is totally constant. X constant, z square constant 4. So this is 0. So x square z. So x square z. Next with respect to z, x square yz with respect to z, this is 1. That is x square y plus here 4x z square, just z square derivative is 2z, 2 4 ja 8, so 8xz, 8xz. Partial differentiation of this function with respect to z, z is 1, here z is 1 and z square is 2z, so 2 4 ja 8 xz, and this is x square y. So this is del phi, and if you want to substitute that point also, or finally you substitute del pi at 1 minus 2 1 is this one. What is that? J bar plus 6k bar. Now let's calculate A cap. A cap is equal to A bar by magnitude of A bar. So 2y bar minus J bar minus 2k bar. This is A bar. And this absolute of this. So absolute of 2 derivatives 2 square. Absolute of this, what is that? Magnitude means suppose A bar, R bar is equal to xi bar plus yj bar plus zk bar, zk bar. Then magnitude, what is the magnitude? This is square root of I bar component x square, j bar component y square, z square. So similarly here, A bar 2 square minus 1 square, k bar minus 2 square 4. So this is 4 plus 4 8 9. So this is A cap. Now the required directional derivative at 1 minus 2 1 in the direction of this 2i bar minus j bar minus 2k bar. So what is this? Del pi dot A cap. Del pi, this is del pi dot A cap. A cap is this 2i minus j bar minus 2k bar. So j dot j is 1, k dot k, 6 to the 12 minus 2 Here there is no I bar component, so that is 0. So this is equal to minus 13 by 3. This is the directional derivative of the scalar point function phi at the point 1 minus 2 1 in the direction of this A bar, the directional derivative. Similarly, we can find the unit normal vector. So what is unit normal vector? The unit normal vector is denoted by n cap. Here phi is any scalar point function or surface. The unit normal vector normal to the surface. Normal to the surface. This is a phi is any scalar surface. Normal to this is n cap. Normal to that surface n cap is equal del pi by modulus of del pi or absolute over its magnitude of del pi. Del pi by magnitude of del pi. Del pi is this. A magnitude of del pi is already this. So this is a unit normal vector formula del pi by magnitude of del pi. Now let's go to the problem. Find the unit normal vector, normal to the unit vector normal to the surface. What is the surface equation? Is y is equal to x square plus y square plus z square, right? This is a phi at the point 1 comma 1 comma 1. Now let phi is equal to x square plus y square plus z square minus 3 is the surface equation. Now n cap denote the unit vector normal to the surface phi. So n cap is equal del pi by modulus of del pi is the formula. Now what is del pi? First calculate del pi. Del pi is one, right? Normal to the surface. This is not log. This is a long equation, not log. Yes, the surface equation is x square plus y square plus z square minus this is the surface equation. So now I bar of dou by dou x into this surface equation x square plus y square plus z square minus 3. With respect to x, 2x I bar. With respect to y, 2y j bar. With respect to z, 2z k bar. Bas this one. 2x I bar 2y j bar 2z k bar. At the point, just substitute the point. So n cap is equal to del pi by magnitude of del pi. Del pi is this. Its magnitude is 2 square, square root of 2 square plus 2 square plus 2 square. So this is 3. 2 root 3. Here 2 gets cancelled. Na? So this one n cap is equal to this one. I bar j bar plus k bar by root 3. This is n cap. Unit normal vector. Similarly, find the unit vector normal to the surface. Similar problem. So partially differentiate this x square y plus 2xz with respect to x, with respect to y, with respect to z. Right? Del pi with respect to and find where x square with respect to x to xy, where x is 1, so 2z. What is that? Dou by dou x of this x square y plus 2xz with respect to x. So this is 2xy plus 2z. 2xy plus 2z. With respect to y, dou by dou y of this x square y plus 2xz. With respect to y, x square, this is 0. Only x square, this is 0. And with respect to z, partial derivative, 2x square y plus 2xz. X square y is 0 with respect to 2xz. Z is 1. So 2x. This is 2x. So 2x. At 2 minus 2, 3. Right? So this is equal to this one. Minus 2i plus 4j plus 4k. The unit vector normal to the surface is n cap is equal to del pi by modulus of del pi. That's all. This is the unit vector normal to the surface. Next, angle between the surfaces. The two surface equations are given, phi 1, comma phi 2. Sorry. So how we calculate the angle between the surfaces? Here let theta be the angle between the surfaces phi 1 of x comma y comma z. This is one surface equal to C1 and phi 2 x comma y comma z equal to C2. Then cos theta, the angle is defined by cos theta equal to del pi 1 dot del pi 2 by uh, del pi 1, that's del pi 1 magnitude and del pi 2 magnitude, both magnitudes. Right? You know del pi equal to n cap, right? N bar. N cap is equal to del pi by modulus of del pi, magnitude of del pi. Only n cap. Only n bar. N bar is only del pi. N bar is del pi. N cap is del pi by modulus of del pi here. Modulus of del pi n cap. The unit normal vector. This is only normal vector. So we can write this is del pi 1 given as n1 bar, del pi 2 let us assume n2 bar, and del pi 1 magnitude is n1 bar, del pi 2 magnitude is n2 bar. Either this or whatever you take, just you calculate the angle between the surfaces. Right? two surface equations. Now find the angle between the surfaces. What is that? X square plus y square plus z square equal to 9 or minus 9 equal to 0. And z is equal to x square plus y square minus 3 at the point 2 minus 1 2. At this point just calculate between in the angle angle between these two surfaces. So what are the surface equations here? Phi 1 equal to, you can write x square plus y square plus z square minus 9 is the surface, and phi 2 is equal to x square plus y square, z send this side, minus z minus 3. These two are surface equations. Now calculate del pi 1 and del pi 2. Right? Del pi 1, what is that? Pi 1 equation x square plus y square plus z square minus 9. Partial differentiation of this with respect to x. X square derivative is 2x. Right? Remaining with respect to x 0, and this is also 0, this is 0. So 2x, simply 2x. With respect to y square derivative is 2y, and x square derivative is 0, z square derivative is 0, 9 is also 0, so 2y. And with respect to z, x square derivative is 0, with respect to z, y square derivative is 0, z square derivative is 2z, and minus 9 is 0. So let's calculate this one. So del pi 1 is 2x I bar, 2y j bar, right? 2z k bar. This is the del pi 1. And del pi 1 at the point 2 minus 1 2. The substitute point x is equal to 2. So 2 to the 4 I bar, and y is equal to minus 1. So minus 2 j bar, and z is equal to 2 to the 4 k bar. This is del pi 1. Del pi 1 is equal to 4 I bar minus 2 j bar plus 4 k bar. This is del pi 1. Similarly, calculate del pi 2. What is del pi 2? I bar dou by dou x plus j bar dou by dou y k bar dou by z. Pi 2. What is the pi 2 equation? Pi 2 equation x square plus y square minus z minus 3. So with respect to x, derivative of x square is 2x. Derivative of y square 0. With respect to partial derivative with respect to x, y is constant, z is also constant, and constant is also constant. This is 0, this is 0. So 2x I bar. With respect to y, x square derivative is 0, z square derivative is 0, 3 derivative is 0 with respect to x. Y with respect to y square derivative is 2y j bar. And with respect to z, x square derivative is 0, y square derivative is 0, and z derivative is minus 1, and 3 derivative is 0. So 2x bar 2y j bar minus k bar. This is del pi 2. Now let's calculate del pi 2 at 2 minus 1 2. So substitute x is equal to, so that is 2 to the 4 I bar minus 1 2 j bar and minus k bar. Now let's write the formula. Cos theta is equal del pi 1 dot del pi 2 by modulus of del pi 2 and modulus of del pi 2. Right? Now this is dot product between these two. I dot I. So 1 4 4 just 16. J dot J, 4 4 just 16 minus 2 into 2 minus 4. Next J dot J is 1. K dot K is 1. So minus 4. Right. This is minus into minus plus 4. This is minus 2, and this is also minus 2 to the 4, and 4 into minus 1 is a plus minus, cancel, minus 4 plus, so 16. And modulus of this, so 4 square 2 square 4, 4 square is 16. Here 4 square 16, 2 square 4, 1 square is 1. So just simplify this. 32 4 36, and this is 21. So 36 root is 3 and 21. So this is equal to 16 or 8 by 3 root 21. This is called angle between two surfaces, or theta is equal to cos inverse of this 8 by 3 root 21. This is the angle between the surfaces. Now, some problem here. If r bar is xi bar plus yj bar plus zk bar, you revise. Then prove that the following grad r means del r equal to r bar by r del r. Next, number 2, grad r or grad 1 by r equal to minus r bar by r cube. Number 3, del into or grad a bar dot r bar equal to a bar grad. There is no product between das or cross product, only shall del bracket start a bar dot r bar is a bar, where a bar is a constant vector. Number 4 is, what is 4, del r or grad r power n. Del r power n and grad r power n is n into r power n minus 2 r bar. Just using this r bar, we can prove this 4. Right? First, you take r bar is a position vector, and what is its magnitude? Modulus of r bar is x square plus, what is that? R bar is x I bar y j bar z k bar, and its magnitude is this x square plus y square plus z square and square root. Now both sides squaring, so r square is equal to x square plus y square plus z square. Is it right? This is not vector here, because magnitude is a quantity, not vector. No? So scalar. Partially differentiate with respect to x, the above equation. So r square derivative is, here r square is equal to x square plus y square plus z square. Partially differentiate with respect to x. So r square derivative is 2r, and derivative of r with respect to x, dou r by dou x, because r function of x, y, z. No? So this is equal to 2x, x square derivative is 2x, y square derivative 0, z square derivative is also 0 partially. So 2 gets cancelled, right? So dou r by dou x is equal to x by r. This is similarly with respect to y, with respect to z, right? So with respect to y, so dou r by dou y equal to y by r. With respect to z, dou r by dou z is z by r. That's all. This is x by r, y by r, z by r. What is that? By taking partial differentiation. So now let's take first one. Grad r del r I bar dou by dou x, j bar dou y, k bar dou by dou z, r, not r bar, only r. So dou r by dou x, j bar dou r by dou y, k bar dou r by dou z. What is dou r by dou x? Just we proved x by r. Dou r by dou y, y by r. Dou r by dou z, z by r. So xi bar, yj bar plus zk bar. What is this? This is r bar, and LCM is r. So r bar by r is grad phi, or simply del phi. Similarly, second one, grad 1 by r is equal del 1 by r. So partially differentiate 1 by r with respect to, right, x. So minus 1 by r square dou r by dou x, minus 1 by r square dou r by dou z, minus 1 by r square dou r by dou z. So dou r by dou x by dou r is x by r, y by r, z by r, dou r by dou z, dou r by. So LCM xi bar, yj bar, zk bar minus take out. So r cube, r cube, r cube. So minus r bar by r cube, right? And next, a bar is this one. A bar, A1, A2, A3 are constant. So A bar dot R bar is A1. Just to dot product between these two, Y dot Y1, J dot J1, K dot K1. So this is del. Let's multiply with del. And let's take this partial derivative of this with respect to x, with respect to y, with respect to z. So with respect to x, a1, with respect to this is 0, this is 0, and this is 0, this is 0 with respect to y. And this is 0 with respect to z, this is 0. So a3. So this is a bar. The next, fourth one, this is del r power n is n into r power n minus 2 r bar. Just you take del r power n, n into r power n minus 1 dou r by dou x with respect to y, n into r power n dou r by dou y. This is with respect to y, right? And with respect to z, with respect to z. So dou x by dou r by dou x is x by r, dou r by dou y by r, dou r by dou z. So x by r, y by r, z by r. So n into r power n minus 1 take out. So this is LCM xi bar, yj bar, r common. So r power n minus 1, this is one more r power n minus 2, this is r bar. So this is about, thank you very much.